Yes, there was someone speaking except Blessing. Who's that? Or was the issue the issue was about the recording? Okay, it's fine. Let's continue. So, what I was saying is that Mr. Luo asked me to be on his behalf for today, and hopefully, I think by next week, whatever is busy with, will be done. So this to next week, the chances are very high that we'll be taking over some chapters for this module. So what I forgot to share with you last week is that I will share the memorandum for um, the two quizzes that you wrote, so that you can have an idea on what is how the best way of answering questions. Yes, Mr. Mabunda.
So I just need clarity, Nyana, on this coming test, are we gonna write your part only?
Yes, my part only. Whatever we are going to cover today, it has nothing to do with test one. It means blessing. You are simply saying you didn't come to my tutorials on Thursday, on Wednesday last week, because we discussed that. But I know you are not the only one. The attendance was not good at all, because I had people were writing, so people decided not to come to class, which is not a good thing. Um, it's based on what we covered until last week, Mr. Mabunda. Whatever we're doing today, I don't want to confuse you guys. Whatever we're doing today, it has nothing to do with test one. Whatever we're doing today, it has nothing to do with what first test. I hope that one is clear. So, but we it's very very important to link, because if you can check here, I just edited the what the chapter that we covered, chapter 2. It was completely randomized design. That was the name of the design, right? CRD. But now what I just did now, I just decided to put what a B. Now it's still completely a randomized block design. It means now, how many factors are we having now? At first, we said when it's like this, how many factors do we have? It's only one, isn't it? That's why we used to call it a single factor design. Now, if I introduce another one, call it B, it means now we have how many factors? We have two factors. So this design, sometimes they call it two-factor design. You can call it two-factor design because now our focus is on two things. Now our focus will be on the treatments and the new variable, which is a what? Is the block. So we today we have to discuss what is the use of blocking. So whatever we did under chapter 2, we're still going to do everything. We're still going to do the ANOVA table, do the pairwise comparison wherever it's necessary, um, do the Butler's test, do the Hartley's test, everything that we covered under chapter 2. We're still going to do something like that, but using a different design. So you must know that we're still going to construct the ANOVA table and use that ANOVA table to test. You do pairwise comparison if it's necessary for the treatments. Because why are we specific that you do the pairwise comparison for the treatments? The only reason for bringing in the block is to control what the error, is to try to reduce what the standard error. So by bringing in the blocks, we're trying to get rid of biasness. In most cases, not possible that we can deal with biasness completely, but we can try to be what? To do better than what the CRD can do. We spoke about randomization, that randomization means assigning of treatment to experimental unit at random, so as for a balance to avoid what? This is to avoid the biasness. We spoke about extraneous variables. These are the things that can affect our experiments, but whenever we're conducting an experiment, our focus is not on these type of variables, extraneous variables, but there's a possibility that as you are busy with the experiment, some of these things can come in and affect your results. So I decided to prepare a detailed introduction of randomization block design. So I will share this note with you. We'll go through the notes. Wherever you don't understand, you can simply come to me and ask for clarity. Again, now I had to introduce a direct control before the blocking. What do we mean when we say direct control? It's possible that you can conduct an experiment and you find that that experiment focused on a certain angle. There's an example that I gave here. Here's an example. Like, suppose you want to conduct an experiment, and if gender is one of the variables that are needed to be part of what? The experiment. When you talk about gender, we're talking about two things, isn't it? We're talking about males and females. But if you notice that most of the things that are being asked are related to the females, you can decide to do what? You can decide to remove what? The male part and only focus on the female part. That's what that's what we call it what? A direct control. Because we know that we are saying we're going to control by gender, but inside gender, still going to cut something. You're going to take out what? You're going to ignore the male part and only focus on the female part. That's the direct control. But please go through this detailed file. So our focus is on this one, guys. Our focus is on the blocking part. Why do we have to block? Or let's go back to the other two. What are the other two basic principles of experimental design, except this one? And what is your understanding on those first two? What are the other two uh, principles, basic principles of experimental design that you know? Let's name them first. Let's name them. Yes, Maruleke. Let's name them first before explaining them.
It's randomization and replication.
Randomization and replication. Thank you. Then I think Smanga gave us the reason for randomization is there, which is true. It's also used to remove the effect of nuisance factors. But that one, if we can check, we're talking about three basic principles. When we're dealing with CRD, complete randomized design, the blocking part does not fit in. So now we want to come up with an experiment which will bring in the what? we'll bring in the blocking, which is the third what? Principle. So now we're going to apply all of them now. We're going to make sure that whenever we come up with an experiment, randomization is there, blocking is there, replication of an experiment is there. So it means now the design that we're going to come up with, it will have the three basic principles. So blocking is a form of control where an experimental unit are grouped into homogeneous sets and the treatment and then assigned to the blocks. Let's understand this statement. Let's understand this statement, leaders. Let's understand this statement. It says blocking is a form of control whereby the experimental units, you know what's an experimental unit, leaders? Now we'll move to an example so that we make sure that it fits whatever the definition says. It says blocking is a form of control whereby experimental units are grouped into homogeneous sets, and then you see now the assigning, the randomization comes in after you have done with what? When you have done with the blocking part. It means the first thing that you do, you introduce the block, and then within each block you will come up with what? Within each and every block you will come up with the so I want us to first do this, come up with the CRD part. From there I will move to the what? To the completely randomized block design part, so that you can see the difference. But we want to make sure that it fits what the definition that is given here, because it says and the treatment and then assigned at random within each block. So now let's go back to our class example, the one that we discussed about the teaching methods. You know what is an experimental unit now. So in a case of CRD, because these chapters that are related, guys. Well, you have to understand why are we moving to the blocks now. So let me take you back to the CRD part. CRD part is an example that we discussed during the course of when we're busy with chapter 2. We said suppose you have I said suppose you have 15 students. 15 students. In this case, the 15 students becomes our what? The 15 students become our experimental unit, because experimental unit. You know about this example, the one where we spoke about the three teaching methods. So we have 15 students. Maybe we can name them by using letters. We have 15 students named A, B, C. Letter 15 is what? Letter 15 when we're using the alphabet is what? Because I want 15 students represented by 10, guys. J is number 10. Yeah, someone is helping me here. Someone is saying N. You, Mr. Svula. O. So it means, suppose we have 15 students represented by letters. A represents student A, B, student B, and so forth up to, so that it can cover what? Our 50. We agreed that we're having three teaching methods, isn't it? We're having 3 teaching methods. And now, what do we do here? We spoke about what? Randomization. Randomization, isn't it? Randomization. So we'll randomization, even here, randomization. Randomization of what? Of the 3 teaching methods. The 3 teaching methods, we agree that these are what? These are the treatments. We spoke about online teaching, video, those who are watching the videos, and venue-based. We spoke about this. This is a case of what? It's a case of CRD, where 15 students, which we call them, these are what? These are your experimental units. You want them to do, you want to avoid the biasness by doing what? By applying randomization. So you'll go to this what? This jar where you have 15 students and do what? And shuffle, isn't it? You shuffle and then you come up with a name. And then again, you go to the 3 teaching methods. You do the same thing. Teaching method, where we spoke of a teaching method. This is the jar of teaching method. Let's say you come up with the letter B, and then it means we have to still go to what? To the teaching method, because you want to know which name will go with what. This name will go with which method. And suppose you do the shuffling here, and you come up with video what? Video watching. So it means to that B will be assigned to what? To video watching method. And you do the same. Suppose then the one that comes in is K, and then when you come to the teaching method, you come up with what? Online teaching. So K will be assigned to this one. So you repeat the statement, you repeat the method until you are done with what? The 15 students. So what do you call this method? Whatever we'll be doing here, if we repeat this, let's say we come up with J now, A, and so forth, until we were done with everything, C, M, N, and so forth. You see, whatever we're doing now, we're doing what? Replication. So you see, randomization is covered, replication is covered. So how does this CRD design differ with um, what? Differ with the randomized block design? So suppose we are worried that no, we feel like there's a, a, a variable which can help us to get better results. You see, whenever we're selecting these 15 students, we didn't care about their gender, right? So suppose someone can say, no, let's control our experiment by what? By gender. Let's bring in the gender first before we can do this randomization and all these things. Let's first do what? Let's first control the experiment. So it means you are going to block. You have to group what? You have to group the students by gender first. Remember, you have 15 students. So if you want to do that, it means now we are saying the methods are fine, but we feel like there's a pathway which is affected. So if we can bring in the gender, it can make a what? It can make a difference. So what you do now, you will still have your what? You will still have your experimental units, which are what? Those students A, B, up to, someone said N, right? Some O said O. Now, According to the definition of blocking, you first divide, or let me share the thing with you so that you can see what I'm talking about. What is that document? I want to go back to that definition so that you understand the definition. Now want to follow what the definition says. It says blocking is a form of control whereby experimental units are grouped. Experimental units are grouped into homogeneous set. Let's stop there. Where experimental units are grouped into. So now let's go back to that. Yes, our experimental unit. The definition of blocking says we should first group this into what? A homogeneous set. So for gender, because we're saying we want to bring in gender, we're expecting male or female. So according to the definition, it says, no, before you can do anything, divide these students based on their gender. So it means from the 15 students, suppose we have 8 males, or let's make it 16 so that the problem can be balanced. If we have to have 16 students, it means it's A up to what? N. Is it N? If we want to have 15 students, up to P. So suppose our last student here is P. I want us to have 16 students, 16 experimental units, 16 students. So according to the definition of blocking, you control the experiment by what? By a certain variable. For our case, we decided to say, no, before we can start assigning these students to these methods, let's first divide them based on their gender. So suppose in our experiment, maybe we had what? We had 10 males, or 9. How many are left now? 9 males and 7 females. So you see what is happening now? We divided the experiment into what? Into the groups. So this is what? Whatever we're having now, this is what? This is block 1. Block 1. Gender is what? Our gender is becoming a what? A block now. Because we're controlling using what? We're controlling using what? So this gender is your what? Is the blocking variable. It's a blocking variable. Now, we have to continue with the definition. What is the definition saying? Definition is saying now we manage to divide into homogeneous groups. If you have a question, please I will stop. The file is coming. So now we're done with what? Dividing the experimental units. Yes, homo.
Sir,
Yes.
we have more than one blocking factor.
Sorry?
Is it possible to have more than one blocking factor?
Yes. Thank you very much. It's possible. But that one, it will be covered under chapter 5. When you get to chapter 5, you can have more than one blocking factor. I think we'll stop at how many? Glycolatine square design is having 3 blocking factors. So there will be a section where you have 2 blocking factors, and you'll cover another section where you have 3 blocking factors. Now, the section that we're dealing with it now is when we're having only 1 blocking factor. When we move to chapter 5, you'll have 2 blocking factors, and there's another section where you can have 3 blocking factors. Did I answer a question, Pash? Pasha? Pash?
I got it, sir.
Thank you very much. Now, oh, sorry, I was about to explain that definition. Sorry. Let's check the remaining part of the definition, because it's very, very important, guys, to understand the theory behind before we move to the calculations. Because if you don't understand the theory, why are you doing the calculations? And treatments. Now we're focusing on this part now. Now the treatments are then assigned at random within each block. Within each block. So what is going to happen now? Randomization is coming back. Randomization now is coming back. So you are done with the block. Now you introduce the variable gender with 9 males and 7 females. So what you want to do now, you want to bring in the 3 methods. The 3 methods. The 3 methods to each and every what? To each and every block. Remember, we have 3 methods: online teaching, video, video, venue based. Same applies to this one, venue based, video, online teaching. So it means now we're having fact, because these are what? Whatever we get now, we're going to do the comparison. But now we're going to check if bringing in the blocks was effective or not. How do you know if it was effective? If blocks are significant, if they were, when you test and you reject the null hypothesis that blocking was not effective, it means you're simply saying by bringing in the blocks, it helped us to improve our experiment. So that's why now we're having what? So when you test, you'll be testing for the blocks and you'll be testing for the treatments. Yes, Mr. Malek. Anyone who can hear Mr. Malek?
Oh, sir, can you please repeat what you just said?
Oh, I was saying, now, after we have to test when we construct an ANOVA table. Maybe that one will be linked with what I'm about to write here. Yij. Whenever you introduce the block, you must check if by bringing in that block, was it effective or not? Because now the model now that will be fitting now is what? Is this new model now. The one that we fitted before, it was having what? It didn't have what? It didn't have the blocks. So when you test, you'll be testing for the treatments. Testing for the treatment means it's this one here, the tau. If you want to test for the blocks, now you will test for this one. If you reject the null hypothesis that blocks were not effective, it means by bringing in the blocks helped you to improve what? The experiment. And another reason to do that is to reduce what? Is to reduce the standard error. But again, even though we're still far from covering that chapter, which is chapter 5, even the complete randomized block design, there's some disadvantages. For example, there's an example that I prepared here. I want us to now to shift and focus on that example. The disadvantages of some disadvantages that we can have when we are dealing with what? Completely randomized block design. Even the CRD. I will give you an example of the CRD now. The disadvantages that we may have when you are not controlling an experiment. So I'm begging you guys, please, when I give you these notes, go through them. Wherever I don't understand, come, let's discuss. So let's focus on this. So now we're done with the definition. So it says now, let's continue. By when it's break, please let me know. By grouping the unit into sets, we can in the analysis remove the effect of what? Of the blocking variable from an experimental error. That makes for more precise comparisons of the means. You see, by bringing in the blocking, it can help us to reduce what? The standard error. Here it is. Whatever I'm saying is indicated here. More precise, the purpose of blocking is to reduce the standard deviation of an experimental error. You see it, guys? That is the purpose for what? The purpose for blocking is to reduce the standard deviation of the experimental error. But blocking will eliminate altogether the effect of extraneous variable in practice. But it's possible that you cannot remove all the problems, but you will try to reduce these problems compared to when we are dealing with what? When we are dealing with the CRD problem. So let me show you an example of CRD now when coming to blocking in the form of an example now. Let's look at this example. This is something that you'll be able to, something that you know, guys. The example that I tried to look for is the example that you can also imagine the situation. So let's check this example. Suppose the researcher want to compare 4 brands of tires. I assume everyone knows what's a tire, isn't it? You don't want pictures of trend whereby having the tires put in a car and driven. Suppose that the researcher want to compare 4 brands of tires using 4 different cars. And suppose that there are 4 cars available. So if we're having 4 cars, guys, and each and every car need how many tires? Need 4. So it means we'll need what? We have 16 positions because you need two tires at the front and 2 at the back, isn't it? So, but you must indicate what the side, the position. Like for example, looking at this table, left front, this one you understand, isn't it? Is the tire in front, the left side. This one is the tire in front, but on the right side. Left rear, this is the tire at the back, but on the what? On the left side. The other one is a tire on the at the back, or for what? On the right side. So suppose that the 4 cars available with 16 tires positions. Well, we understand what's a position now. One possible design can be CRD. It's true. We can have a CRD problem. We can solve this as a CRD problem. Randomly assign the what? Assign 16 of the tires to the 4 brands, the cars. Yes.
It's
Mabunda,
time, sir. It's break
is it,
time.
or it's break? So it's fine.
Yes.
Someone's hand is up again. Can you please allow me just to finish the statement that I wanted to say? Can you please allow me to do that, Mr.
Yes. Yeah, I can finish.
Okay. I will come in, Mr. Manyama. I will come now. I will attend to. So here are the results, guys. I just want to explain the meaning of this table so that when we come back for break, I will continue with the other table. So the meaning of this is that, remember, you have 4 brands, isn't it? 4 brand A up to brand D. Let me indicate it here. I'll give you a minute, Mr. Mawanda. You don't have to worry. Brand A, brand B, brand C, brand D. So if you can check here, car 1, I want to explain the meaning of this A, B, and C. Car 1, the tire that is on the left side in front is from brand A. The tire on the right side is right, but in front is from brand C. And at the back, we have from left and right, we have what? Brand A, brand A. So if you can see, car A, almost everything is brand what? Is brand A. Car B, car 2, CB, it means this one is from brand C, brand B, brand A, and brand B. But you must be careful, where is the tire positioned? So when you come back from break, I will continue with my explanation. Thank you. Mr. Manyama, so now it's 57. You can add your minute, Mr. Mabunda. What time are we supposed to come back? Mabunda, what time? Musibudi? Musibudi? 12:06. Okay, it's fine. Let's come back at 12:06. Anyama, if you can hear me, I'm waiting for you. So let's break for that.
Morning, sir.
For those minutes. Hey, Tavis.
How are you, sir?
I'm fine, and you, Mr. Manyama?
I'm good, sir. Myself, I'm just curious in that matter of us doing the programming part for the states, since it seems like we don't have time on our side. And on first year, they allowed those first year students to go and attend venue-based practicals. So I wanted to understand.
Can I come in, Mr. Manyama? I think the issue was also raised last week. So I went to the lab. So they told me the procedure now of applying, but the only challenge that we'll have, because the class size is 305, and the only lab that we have that they can try to give us for the week that we want the practicals can only accommodate 100 students. So now we're at the situation where even if we are moving to the practical part, we cannot go there all of us. The venue that they have, the biggest venue that they have, can only take 100 students. And the question is, you cannot attend practicals for an hour. It's not going to be a practical for an hour. By the time we finish, we won't be you won't gain a lot of things. So we need enough, maybe 2 hours if possible, for each and every session. So assuming that we have to do this in one day, so it means we need 6 hours. I had to be at the lab for 6 hours. So those are some of the challenges that we're facing now. But he promised me that he would see if there's another alternative that he can give us. So I'm still waiting for him to get back to me. I went to him last week to ask about the practical issue and the venues.
Sir,
Leadership.
myself,
Hello.
Yes. Can we can we hear what the other leader is saying?
Leadership.
Yes, Ntago.
Hello. Yes. I
Yes,
was asking, are you available tomorrow for consultation?
I'm available today.
Today I'm not around. I don't know whether you will be available tomorrow.
Tomorrow I'm not sure, but keep on touch with your class reps. The class rep, you can ask the class reps for my availability tomorrow, and then they will check with me. It's easier when
Oh,
it's come via the class rep because we have another way of communicating, except the what the on the what the email. So you can send an email and also ask your class reps for my availability concerning tomorrow.
I think it is also advisable to tell them just to post on the group, on the WhatsApp group, when are you available for consultation and when are you not available and what time.
No. Oh, you mean for if you mean for that, I think it's indicated from the class thing.
No, I'm not. I mean for tomorrow.
Oh, because that one I think it will be a special case. Usually, if I'm
Yeah.
in, I inform them. Usually, when I'm in and I'm
o-
find that I'm not supposed to be in, I usually inform them that whoever want to see me can come.
Okay.
So it's not a big deal, leadership. Whenever you want to see me, whenever I'm coming in, I'm in the office and I'm not supposed to be in the office, or I'm in the office but it's not consultation time, and I want you guys to come if you are available. I usually indicate, tell my leaders that please, whoever want to see me can simply come now. So that one is not a
Okay.
big deal. People have been coming here, but you can try to come, my brother, today. Oh, why do you mean when you say you're far? Far, you're at Gyan.
I'm in Zanin.
Oh, Janin is not far.
Yeah, but I'm having a class after this. I don't know.
Oh, no, no,
It
it's,
will
I
be late
understand.
if
It's fine, my brother.
yeah.
It's fine. Okay. Yeah. Mr.
I'll
Manyama?
just keep on trying.
Okay. Mr. Manyama?
sir, I
Yes.
was about to tell you that I engaged with that guy, or the white guy who is responsible for governing those labs for computer science, and
It's not that one. It's not that one. The one that was
that's why
responsible.
myself I'm saying you said for statistics the room is so small for us. I myself
Yes.
I say I went to speak with the guy for computer science asking if maybe you can let us access computer science labs too. Then he said you can come with a letter from your lecturers. We can give you those labs for an accumulated time, together with that one for statistics, so that we can do the program. Because myself, I'm hungry. Like, I want to know programming and go and vacate. Next, we're
So
only left with 3 months to go and work. But if we don't know programming, it's a problem.
I agree with you, Mr. Manya. But now I heard you saying if we can get the other two, it's not going to help us with anything because I'll be the one teaching. Even if you get two venues, who will be teaching the other side? Do you understand, Mr. Manya?
So what you are saying is that you are the only one who's teaching this programming.
No, I'm going to teach you programming based on the module. I'm not going to teach you programming in general. Now, the programming that I'm going to teach you is based on what we are currently doing now.
Okay,
So
sir.
we can continue after break.
Can I add on
The
that
what?
one? Yeah, the venue part. Like, it's not necessarily going to the lab to teach us the programming part.
Oh,
In first year we were doing C++, and then Majuda was teaching us C++ at TA. So teaching us programming doesn't require labs.
oh, so you are simply saying you can do your part by installing the packages.
No, for that one, we can request for them to be installed in our machines, and then after for lessons, that's where we're going to do the venue based, maybe with TA or somewhere. But now, okay, it's fine. I was just AD. It was just a CGC.
Thank you, Sacramento.
Unless if I didn't get your point, leadership. You are saying there's no need for us to go to the venue. I can simply teach like the way I'm doing now.
No, it's saying even though we don't go to the labs, we can go. We pick a room where
Oh,
it can
we
accommodate
can
all
go
of
to
us.
TA.
TC, yeah,
Oh,
TA, TC.
oh, we request that one, and then you come with your laptops. Is what you're saying?
Yes.
Yes, 100%.
Oh, so I think that one maybe that one can be a better solution. In fact, because I'll be projecting there, and then you guys will be working. Let me try that
Yeah.
one.
Sir,
Yes, Mabunda. Hello.
sir,
Yes.
yeah, we can continue.
Thank you very
Maragari, we are
much.
still talking here.
We are still talking, Mara. Break time is over.
Mara, guys, Pella, this is part of the monitoring.
Sacramento. We're done. We agreed that we can. So we are done, Sacramento. We agreed that we can move to the venue base. I'll talk to my HOD now.
Oh, okay. All right.
Yes. Sure.
Yeah.
Leaders, let's go to. Can someone explain? I want to check if there's someone who understood the meaning of these letters here. Can someone explain the meaning of these letters to the class, please? Anyone who understood what I was saying? We can pick any car. Yes, Makwelel.
But it's fine. I think because you have already added continuation of class, I just want to comment on the discussion that was on during the break there. But maybe we can add it on after the class.
It's fine. It's still fine.
Okay.
So
I just want to
explain.
comment on the. Huh?
Yeah, you can continue.
Okay. I just wanted to confirm. To comment on the supplemental suggestion of the using any any class, I mean, because not every computer can handle those kind of softwares. You have to be mindful of that, because the RAMs are not the same, not as huge as they can be at the lab. So you need to be mindful of that.
Can I, can I come in, Makwelele? I think
All
yes,
right.
you are right. Let's. I will reserve time towards the end of the class so that we can discuss this issue. Can you please now
All right.
focus on the business of the day, which
Yeah.
is yes, that one I will reserve maybe 15 minutes towards the end of the lecture. Uh, uh, Musibudi, Musibudi,
Say
what time are we supposed to end the class?
12:40.
12:40.
Yes.
And
12
what time is it?
12:50 because
12:50.
of Rubili.
12.
Okay, so it's fine. Let's end it at 12:40 so that we can continue with this discussion, this issue of practicals and so forth. So when it's 12:40, please let me know.
Okay.
Yes. So the what I was saying about this table is that we have 4 cars, 4 different cars, and what to fit these tires, these 4 brands, to what? To these 4 cars. But if you can check, car A, almost all the tires are from brand A. Let's see what is it. What is the issue with car 3? Or what? Let's talk at let's focus on car 2. Car 2 is only exposed to what? Brand C, brand B, brand B, and brand A. Brand D is not there. You see? So now, to emphasize, this is a result of assigning brands completely at random to the 16 tire positions. Yes, Medzi.
Yeah, yes.
Yes, my brother.
So I need to know whether each brand contain only 4 tires or they can contain more.
No, we agree that here it is. You have 4 brands. You have 4 brands, which is brand A, brand B, brand C, brand D. Right? So
Yeah.
it means you have 4 tires from each brand, right?
Okay.
We have 4 tires from each brand, which you want to fit these tires to what? To the 4 cars. But you cannot say car 1, let car 1 take brand A, let car 2 take brand B, let car 3 take brand C, and car 4 take brand D. There's an issue there, isn't it, my brother? There will be a serious issue there. Because now, you know cars, right? The tires that are there, if we put tires in front, and we cannot say no, brand A should be for the left, for the what, the tire on the in front, but on the left side. Let's say for this column here, or let me come to go to the table. So let's say we say no, this our left, from each and every car, we want our left front tire to be from brand A. We go to this one, want our right tire, right front tire to be from brand B. Again, it's wrong like that. You are not doing things randomly. So the issue that now we're having, suppose we come up with this result. We're not saying these are the only results that can come from shuffling, guys. If you shuffle, you can come up with different results. We're just saying, suppose when you want to conduct an experiment, you come up with this randomization. So there is a big problem that we're seeing now from this experiment. What? Because automatically completely randomized design is not a very good design for this experiment. Why? It is possible, like in this time, that 3 tires from the same brand get to put in the same car. Here it is. This is from the same brand, but they're in the same car. Now remember what we're saying. Suppose you want to do this problem using what? Randomized, completely randomized design, CRD. CRD is not a good design for this experiment if we come up with results like this. And again, why are we saying that? If the car is significant extraneous variable, then the resulting comparison between brand will be biased in favor or disfavor of brand A, because, and again, the driver of this car can have an impact in our results, or the car, the way the state of the car. So we need a randomization in such a way that when we bring in the blocks, each and every car should have one of the 4 brands. You see here, this first car is having brand A, brand A, brand A. This car does not have a brand what? B and brand D. When we go to car number 2, it's not exposed to brand D. So there's a problem here. Car number 3 is not exposed to what? Brand A. The last car here is not exposed to brand A again. So we're not happy with an experiment like this. So we want to try to get rid of this problem. Now we come up with a new. You go through that uh, um, um, theory there. So now, suppose now want to bring in the blocks. So numerically, the mean trend wire for brand A might be smaller or larger than the mean trend wire for the other brands. But it may be due to the effect of the car or the driver. So it won't be easy for us to comment about brand A because it's only, I think it will be only effective when coming to car A. But when coming, the mean for brand A, it might be affected because it's exposed to what? Almost 1 car. For C, brand is, for car number 3, the brand is not there. For car number 4, the brand is not there. If the car is having a problem, car 1 is having a problem, it can affect the results of what? It can affect the results of brand A. So that is the meaning of whatever is written here. So now we can try to come up with what? A randomized block design. How do we do that? Now we can use the car as the block. We use the car as the block and assign the 4 brands within each and every block, which is your car. You see now what is happening? We control our experiment now. We use the car. We use the car as the what? As our blocking factor. So it means we're going to have, remember the experimental unit part, we have 16 tires. Now you assign them, you come up with a block. How many blocks are we going to have for this experiment? How many blocks are we going to have? Number of blocks here. For the gender one, I said we'll have block 1 and block 2, or group 1 and group 2. For this one, what is going to happen? If we use car as the block, 4, right? It's true. It's going to be 4 because we have car 1, car 2, car 3, car 4. And assign to the 4 brands within each block and car. Notice that randomization is still possible within blocking. So we know that when we come up with completely randomized block design, randomization is covered. Randomization is to avoid biasness. And again, we want to bring in the block so that we reduce what? The standard deviation of the what? Of the experimental error. So we are saying, and assign the 4 brands within each car. So we want to make sure that each and every car is having what? Each and every car is having one of the brands. So let's check this layout now. Let's check this layout now. Can someone report any issue that you are noticing there? Any issue that you are noticing? Are all the brands represented from each and every car? Someone's hand was up.
Yes,
Yes, let's go. Let's go. Tabiso?
yes, the brands are distributed among those 4 cars. So it means the randomization may be at least maybe within the 4 tires. I don't understand how, but I'm trying to get the sense of how are we going to do this randomization, since we want the 4 tires to be shared amongst the cars. Do you understand my
Yes.
question?
I understand it very well. I understand it very, very, very well. It's fine now. Now I will go back to the whiteboard. But allow me to explain this part here. Even though we managed to make sure that each and every brand is represented, but again, the position also may have an impact. The position where the car, the tire is positioned. Let's check at the left front from all the car, from all the what, the brand there. We have ACDA, right? Well, I'll come back to you, Tabiso. We have ACDA, ACDA. So from all the 4 cars, brand B is not there on the left tire, isn't it? Front left tire. If you check here, brand B is not there. So now again we're having an issue with this design. But this design is going to help us with some problems that we had when we're dealing with what? When we're dealing with CRD. Again, let's check the last one. Right rear, it means at the back, on the right side. There is no car. There is brand brand A is not represented there. But this will be what? Will be dealt with it when we're coming to what? That this is a question that was asked by. This is the question that was asked by Lata Home. That is it possible to have 2 blocking factors? The definition of Latin square design says that each brand should appear once and only once in each row or column. So when we get to chapter 5, we'll bring back this situation. So, sorry for that, guys. My line manager was calling me. This experiment compared to this first one, compared to this one, is better. This experiment, remember, the cars are the blocks. These are the blocks. Get the point? A, B, this A, B, C, D represent what? Represent the brands. So your treatment is what? Is the brand. So you have 4 treatments, and so these are what? These are the treatments. This is what we are treating, guys. The treatments are the what? Are the 4 brands. And then the 4 cars are what? We agree that the 4 cars are the blocking factors. So when you construct an ANOVA table, you'll have to test for what? For the 4 brands, if there's a difference between the means of the 4 brands. And again, you have to test about the 4 cars, if blocking by the cars was effective or not. So, Mr. Manyama, what he was saying, for me to explain it better, I have to go back to the whiteboard. But can I get questions based on this part here before I go back to the whiteboard? Today, I'm not going to do any calculations. What matters is you have to understand the issue. Why do we have to block? What is the main thing that you manage to capture when coming to the why are we supposed to do the blocking? Anything that you manage to get? Why are we blocking? Why are we blocking, guys? Smang. Smanga.
We are removing the nonsense.
Sir,
Yes.
sir, we are blocking to manage the. We are blocking to manage the nuisance factors in order to reduce the error.
Thank you very much. That is the main reason. So you must understand why we are blocking. Because I had a situation where we just rush to what? To do the calculations. People, they don't even know why they are calculating. So you must first understand, why are we introducing this variable? Why are we introducing the blocking variable? Why are we not continuing with the CRD? Because it's even easier to deal with the CRD. But one of the reasons to us is the one that's missed. Is this one? Manyama just said now. So, Mashele, so when coming to the issue raised by yes,
Is the reason for reducing biasness part of blocking?
reducing biasness is covered by randomization, right? But also by blocking is also helping. The blocking is also helping that part, because if we check, if you read this part here, I think it's here. Read this first part. I will share the note with you on leadership.
Yeah.
The first part, this one. Read this part. Only this part before up to here. Because it's here. I think it's here. Let me show you. Sorry. Let me look. Let me check it for you first. Yeah, I will check it for you, but I know it's part of my notes. I'll check it for you, leadership. Ronald. So the analysis part, guys, is not that complicated. It's similar to whatever we've been doing. The differences now will be the formulas that we'll be using, the ANOVA table, and so forth. But I don't think we'll have some challenges when coming to this. So with the remaining 10 minutes, can you please allow me to help Mr. Manyama with regarding his question? Mr. Manyama, yeah, what you can check, you can notice. We're talking about the positions. We're talking about the positions, which is the left front, the right front, and so forth. So what is going to happen, Mr. Manyama, is the following. You want to make sure that each and every brand appears in each and every car. So it means now we need the blocking to come in. So in the form of an example, let me just open a whiteboard and try to summarize with the remaining 10 minutes. So what is happening is that we're having those 16 tires. We have those 16 tires, Mr. Nanyama. And we agreed that our blocks is what? Your block is what, Mr. Manyama?
The block is the cars. It's four. We have four blocks.
Cars, isn't it? It's car 1, car 2, car 3. But whatever we're doing now, we're doing what? We're coming with the block, isn't it? Car 4. We have the 4 cars now. Now, what is going to happen now? Since we have the 4 cars, we come up with what? We come up with randomization, right? Randomization of the what? The randomization of looking at the 4 brands. So it means from each and every car, you'll have the brand, isn't it? A, B, C, D. Even on this one, we'll have A, B, C, D. Again, even for this one, A, B, C, D. So now, what we want to, so you also have 4 here. So now what is left, Mr. Tabisa, is that this brand A, because obvious you must have the 4 represented from each and every car. Do you get the first part, Mr. Manyama? Because now what is left is what? Is the position. You have the 4 positions, isn't it? So suppose we are here. We're focusing on the first one now. We're still on the first one. Brand A is supposed to be where from the car? So you'll have what? The positions here. Left front, left or right front. What is the left? The back one is, we call it what? Left rear and right rear. So, Mr. Manama, what you're going to do is that you're going to shuffle these positions, and then whatever you come up with, you assign it with what? Or you can also randomize this side. You can apply randomization here. Suppose you come up with brand B, and you come to the positions, you do the randomization. Let's say you come with brand B, when you come to the positions, you come up with RR. So it means this one is what? We are going to put this tire at the car 1, but at the back on the right side. You shuffle again on this one. Remember now, the right side is out, brand B is out. You are left with 3 options. You shuffle, suppose you come up with D, you come to the position part, let's say you find LF. So it means this tire will be on the left side, but at the back. You are left with 2 options now. You do the same until you are done. From there, you move to the next one. Do you understand how you do the allocation?
Yes, I do get the sense of what is happening.
Okay. Mara, if it's not enough, feel free to come to the office. I'll be here. So please, whenever you want something, I'm here. Please. Yes, who's talking? Can I get Smanga first before Christopher? Because Christopher, Smanga will fight with me. Smanga, please summarize. We have only 5 minutes and we still have Christopher on the line.
Sir,
Yes.
as you said, on car A, you are going to have 4 brands, and each and every 4 brands are going to shuffle with its position. So is it possible if I shuffle for car 2, then I found that brand B for car 2, it also goes with RR, like I did for car A? Is that possible?
Yes. Yes.
Okay.
That is the situation that we're having, Mr. Smang. Before I can go to Christopher, let me show you exactly what we are saying. That is the issue now that we're having with this design, but is better compared to CRD. CRD is having a lot of issues. It's easier, but it's having a lot of issues. Let me explain what. Yeah, it is. Are you not referring to this, Mr. Smart? You see the situation there. Can you see it? Smanga? Oh, he disappeared. Chris?
Sir, I was saying,
Yes.
you said when we choose the brands, we sample.
Yes, because you cannot say automatically whatever you get is assigned to treatment, to the first treatment, right? Again, we're not solving the issue of biasness here. Let me share that whiteboard. Suppose, Chris, what you're saying is that suppose we don't have this. It means your focus is only on the positions. If you get whatever you get first, let's say it's RR, you come and assign it to this one. Is it fair? What if someone decides to assign it to D? Will you say the person is wrong?
No.
Suppose you get RF. Someone you said to assign it to A. Someone said to assign it to D. Is the person wrong?
No.
No. So we have to come up with a method where there won't be any loopholes when coming to, if people ask, why do you do this? So if we shuffled even on the other side, every element had equal chance to be selected, isn't it?
So when we sample, we use without replacement or with replacement.
No, immediate for this one, because you want to make sure that each and every position is is each and every position should be represented. When you are done with that position, you must remove it so that you are remaining with what? With equal numbers, both sides. Because imagine if we leave RR here, but we already assigned it to B, or RF, we already assigned it to A. So there's a possibility that when we shuffle again, we can get RF and assign it to B again. So now there will be a brand which won't be allocated anything. So that one is still going to create problems.
All right.
Yeah. So it's 1 minute to, guys. In the afternoon, we won't have the tutorials because there's nothing to do. We won't have those tutorials for this week. So use the time wisely. Prepare for the test that we are writing next week. Good luck for all the tests. And again, not dodging our classes when we are writing other tests in advance. I want to say this, that we thank you for doing that, for not dodging our classes when we are writing other assessments. So in the afternoon, there won't be any tutorials. So if you want to see me, you can come between 3 and yeah, we can come from 1 until 3. Let's have that agreement. If you want to see me between 1 and 3, you can come and see me. Yes, I will do that, my brother. I still have to write it down and then scan and share it on the, or I will share it under the content for the 2 quizzes so that you don't make same mistakes again. I will definitely share the solutions.
Sir,
thank
it's time for the discussion.
Thank you. Enjoy.
Sir, it's time for the
Yes.